Our FlashLoan smart contract will interact with a couple of other smart contracts such as Kyber, Uniswap, Wrap Ether, DAI. So in this video, we're going to import the addresses of all these contracts and create a Solidity pointer so that we can interact with this contract. We will also need Solidity interfaces in order to interact with this contract. So for this, you're going to the GitHub repo of EatTheBlocks in the step 23, and you go in contracts, and we're gonna copy over some code. So first, Uniswap v2 router 01. So that's the interface for the smart contract of Uniswap. So you don't need to understand all the function here. We're just going to use a couple of them. So here in my code editor, in the contracts directory, I create this file, Uniswap v2 router 01.sol. I paste everything. Okay, save this. We also going to copy the other interface of Uniswap. So what happened is that Uniswap released this smart contract router 01, but they found a bug in it, so they updated the contract and released router 02, and router 02 inherit from router 01 and customize it. So that's why we need both. Here you can see it import the other contract. So here we copy this, and in contracts directory we create the other interface, Uniswap v2 router 02.sol, and we paste everything. Okay, so back to GitHub, previous folder, and we also need the interface for Wrap Ether. So IWETH. So here we create the interface file, paste everything. Okay, so now we have all the Solidity interface that we need. So now we're going to be back into flashloan.sol, and we're going to import these interfaces. So below this, we're going to import Uniswap v2 router 01.sol, or we need router 02, and after IWETH. Okay, so now we have our two interface, and we also need the interface of Kyber, and that's actually provided by the Money Lego package. So in the GitHub repo, we are going in the flashloan.sol file, and we're gonna copy this because that's a bit long. I don't remember by heart. Okay, so here we import this Kyber network proxy, and we rename it to make it consistent with the naming of the other interfaces. Okay, and after, below the struct, we are going to declare different Solidity pointer to this smart contract. So we start with Kyber. So Kyber network proxy, we call this Kyber. Then for Uniswap, this is going to be Uniswap v2 router 02. We call this Uniswap. Then for Wrap Ether, this is going to be iWith. We call this with. Finally, for DAI, the type is IES20. So these come from Open Zeppelin, and we call this DAI. And finally, we also need a constant here. So that's a constant that will be used to deal with Ether in Kyber. So for that, we go to the smart contract of flashloan.sol in GitHub, and here we will copy paste this. So So here that's a special kind of variable that we call constant, and that allows to save some gas because Solidity knows that it will never change in the lifetime of the smart contract, so it can do some optimization. And after that, we need to instantiate this pointer because here they don't know what is the address, so we cannot use this pointer like this. So for that, we're going to create a constructor. So a constructor is a special function that is called when the smart contract is deployed to the blockchain. So we're going to pass the different addresses. So Kyber address, then Uniswap address, then wrap ether address, and finally the DAI address. Make this public, and inside we're going to instantiate all these pointers. So Kyber equal Kyber network proxy, and we pass the address we got as argument of the constructor. Same thing for Uniswap and the other contract, Uniswap v2 router 02. And so now we can interact with the smart contract, and inside the call function we also going to do a check to make sure that we receive enough token from DYDX. So first we get the balance of DAI here. So we use DAI.balance of, and we pass the address of the contract. And after, we're going to do a require statement. So a require statement allows you to check that a condition is satisfied, and if that is not the case, the whole transaction fails. So the balance of DAI needs to be superior or equal to arb info repay amount, and if that's not the case, then the error message is not enough funds to repay DYDX loan. Okay, so we are done with setting up the addresses of the different smart contracts that we need in flashloan.sol. So we're gonna stop here, and in the next video we're gonna code the first arbitrage from Kyber to Uniswap.